This is Between the Brackets, a Mediawiki podcast, episode 67, August 18th, 2020. Welcome to Between the Brackets. I'm Yaron Koren. My guest for this episode is Albert Kettner, who is a research professor at the Institute of Arctic and Alpine Research at the University of Colorado. He also helps maintain the wiki of the Community Surface Dynamics Modeling System, or CSDMS. I've been talking to Albert for years now because their site uses some of my extensions, but I have to confess that it wasn't until recently that I realized what a big deal CSDMS is. Really, it's a big international organization, and I hope to get into all of that and more in this discussion. So Albert, welcome to the program.
Thank you for having me.
Where are you right now?
I'm located in Boulder, Colorado. You might hear some sort of an accent. I'm originally from the Netherlands, but I moved here 18 years ago. So
I see. Okay. Oh, there have been other Dutch people on the show. No Dutch Americans yet. Where in the Netherlands did you live?
I was born in the south and grew up there most of the time. And then I did a master's in somewhere in the middle of the country at the Agricultural University of Wageningen.
Oh, crazy! I've been to Wageningen.
Oh, cool.
Yeah, I helped with the Wiki project there. Actually, strangely enough, yeah, it's a big international science capital, really, from what I understand, especially in biology. They are strong in biology, strong in environmental research, agricultural research, right? Okay, yeah.
And they're only how many? I think 5 or 6 universities or something in the Netherlands. So, this is one of them.
Yeah. Okay. So, what kind of things do you study when you're not doing wiki stuff?
Yeah, when I'm not doing wiki stuff, let's see. There are 2 main things that I focus on in my research. One is about flooding. So flooding is something that happens, on all continents, and it's affecting millions of people every year. It's costing a huge amount of money, but for some reason, we as a society or we as people cannot handle floods well yet. So what my role in this is using satellite information to map flooding. So it's mostly remote sensing, using open source satellite data, and make maps for the World Food Program or the Red Cross or organizations like that.
I see. Oh, wait, you said open? It's all open source data?
Yeah, so most of the data that I'm using is open source. So there are satellites named Terra and Aqua, and they're having a sensor on board called MODIS. And MODIS is around, or the images of MODIS are around for 20 years. They produce 2 images a day from any location on Earth. And it's basically a photograph from space, right? So it's optical data. So when it's not clouded, you can see with a reasonable resolution, you can see what's happening on the ground. So you can see if it starts flooding or not.
Yeah, okay. That's been big in the news in the last few weeks or months or so with there's a dam in China that looks it would be beyond catastrophic if anything happened to it. I don't know if you're involved in monitoring that at all.
We have been looking at flooding in China for the last 4 weeks, I think. I'm losing track. It could be 5 or 6 even. There's this monsoonal system in China is beyond monsoonal systems we have seen in the recent past, and it's flooding there quite significantly. So the city of Wuhan, which was previous hit by COVID,
Sure.
is now hit by flooding. So Yeah, we're mapping that flood. There was flooding not too long ago in the US with a dam failure actually there. So we're monitoring that. There's typically on a regular day there 4 or 5 places on Earth that are seeing significant flooding. So.
Oh, okay. Yeah, never a dull moment, as they say.
No, yeah. Wow. Yeah, and unfortunately, or maybe for me, unfortunate, is that typically when flooding started, that's when the most busiest period is, when the World Food Program, for example, reaches out and say, hey, can you pin down where the flooding has started? And that typically happens on a Friday afternoon or a Saturday or something, right? So right when you want to celebrate the weekend, that's when, disaster strikes. So
I assume that's just a coincidence.
It is a very coincidence,
okay.
But it feels like it's occurring more right at the weekend.
Really? Okay. Yeah. And of course, it can happen anytime during the day also.
Totally.
Yeah, okay.
Now, we are a little bit dependent on when the images are coming in. So like I said before, for the MODIS satellite, there are 2 images. And so it depends when we get a good view of that area that we can start processing the data. So,
yeah. So moving on to CSDMS, the Community Surface Dynamics Modeling System. What is that?
Yeah. Let's see. What is it? It's basically a community that deals with the Earth's surface. But trying to predict how the Earth's surface is changing, right? How fluxes of sediment and fluids move over the landscape and change the landscape, basically. So landscape got eroded, sediments got transported more downstream, and then at some point it got there's depositioning going on. So forming of deltas at the coast and things like that. This community was started, 2007, I think. And it's basically they're in the modeling world, because it's a community that serves numerical modelers. In the modeling world, there are 3 main communities that try to model Earth. And there's a whole atmospheric modeling community. They're looking at the atmosphere, they're looking at the climate, they try to forecast, they try to better understand the climate, right? That's one community. Then there's another community that looks really into the heart of the Earth, and they're called CIG. And they're more looking at, mental processes and how volcanoes will erupt, and they try to predict where earthquakes will occur and those kind of things. But there wasn't a community really focused on the surface there where everybody lives, right? The Earth surface that we're all using. So we lobbied for several years for the National Science Foundation to give this more attention, and they were at some point happy to support us, and that's what they've ever done so far. So,
yeah, okay. Were you involved with it since the beginning?
Yeah, I was pretty much involved from the beginning. There was so I said at the beginning that so I came here in 2002, and that's where the process of writing white papers, having meetings, starting to form a little group that pushed this forward and lobbied at the National Science Foundation to give this more attention. I was there at the beginning, but then I left for a brief period because I did my defense in the Netherlands. So I had to be there at the university as well, right? They needed to see my face. So I spent it there for a year, and when I came back, the process or the project was about half a year in or something. So.
Oh, okay, yeah. So you were gone for the very beginning of it, but
yep.
But you were also involved in helping to bring it about.
Yes, that's I was a student at this time, so right, not a leader in the field by any means. Not that I'm a leader now in any field, but as a student, you feel kind of, you're more looking up to the professors who are trying to push this forward.
Okay.
But I was involved in that sense. Yeah.
It's based at the University of Colorado?
Yeah, so there is, so CSDMS has a facility basically that supports the community, and that facility is based in Colorado. We're a group of, I lose count, something like 8 people that are directly involved, and maybe another 3 or something that are supporting this facility more. And then with the group of 8, we're organizing annual meetings. We are organizing webinars. We're setting up standards. We're developing software. Yeah. So, and then there's a steering committee that's kind of, they meet twice a year, and they give us advice on, our future path. We're presenting kind of, this is in this direction we want to go, and they're from industry as well as from other universities.
Oh, okay.
So they can kind of guide us what direction they think is most useful for our community.
Yeah.
So.
Just randomly, it seems strange to me that it's called the Community Surface Dynamics Modeling System. It seems like it should be called an organization or consortium.
We wanted to have it a center. This is all a little bit political, I guess. This is the way the National Science Foundation in the US is kind of handling funds. And at first we wanted to have it end like a Community Surface Dynamics Modeling Center. And center is the National Science Foundation has several centers, and they're just operated on a different level, and their funding level is also different. So they said, well, we don't want to have this really a center. So we came up with this.
Okay. It's too late now to change it.
And we can't change it right now. But maybe in future, whenever we, shoot for more support, and maybe outside NSF, then we might be able to change the name. But it's only a name, so it's not.
Yeah. Okay. Right. Well, it's not that easy to say either, but
I agree.
Get used to it. Okay, yeah.
I agree. So one thing that people are saying is, so CSDMS, you can also call it systems. So
systems. Huh.
Yeah, so it's, yeah.
All right. I'll buy it. So you're fully funded by the NSF? That's the only source of funding? National Science
my funding is...
I mean, you being mostly, the CSDMS, sorry.
Yeah, okay. So CSDMS is, I would say, for 80% funded by the National Science Foundation. And then sometimes we got, some consortium money. In the beginning, we had some from the oil industry. That disappeared quite quickly, but
that's interesting.
Yeah, they're interested in how sediment move, especially how sediments get deposited in the ocean. So they have a big interest in that part. So, and then some of us are funded through NASA as well, and so there's. And part of that work is also related to CSDMS. So I would say 80% NSF and then 20% other. USGS is also partly funding this. So.
Yeah. Okay. Oh no, I meant it was interesting that they stopped funding you. I don't know if there's any drama there.
No, not really. Well, drama. It's how you look at it. So the oil companies, they really notice when the barrel price for oil drops, right? They have their own R&D, research and development divisions.
Sure.
And they, as soon as the oil prices drops, they want to keep their own people, so they fund less people outside for research.
Oh, okay.
And that over the course now of 12 or 14 years, we had two big drops in oil price, and one is right now happening. So they just don't want to spend too much money outside their own organization, basically.
Yeah, I get it. Okay, yeah. It's interesting, and your URL is csdms.colorado.edu. I promise this is my last complaint. It's not really a complaint, but until very recently, I thought it was just a science lab at one university, based just on the URL. So I didn't realize that it was, this big international organization. Has there been any thought to getting a more general sounding URL?
So this is something that our university it's always easy to blame somebody else, right? So maybe I should first put the blame on ourselves, that we were too lazy to, purchase a server and have that outside the university firewall kind of set up.
Oh, okay.
What we did was we bought a server, but through our IT department, and they set it up within the firewalls. And one of their constraints is that it should have the colorado.edu address in there.
Right.
So, and they maintain our servers and some of the software that's running there, and they're protecting us from any attack from outside. But it is really a facility that supports mainly the community in the US. So that's our main goal. But we do have many participants from outside the US, from I lost count. The last time I looked, I think it's somewhere 68 or 72 countries around the world that are actually have members to CSDMS.
Wow.
And some of them come to our annual meetings, and we have people from outside the US that are actually part of the steering committee, just so we have an understanding, what is Europe up to for having model platforms, or what is Asia up to for model platforms. So,
wow, yeah. How many members altogether?
Close to 2,000. I think by the end of this year, or maybe early next year, we should have roughly 2,000 members. So.
Wow, yeah.
And it's quite a variable. They're mostly scientists, I would say, but they're also members from national labs, from DOE, Department of Energy, I should say. But
right, there was just a few months ago, there was someone here on this program from the Department of Energy. Actually.
Oh, cool. Yeah. Okay. Yeah. So he I doubt it, but he could be a member. He or she.
Potentially. Yeah. Right.
Yeah.
Be involved in two wikis, because they have their own Wiki Powerpedia.
Oh, cool.
Which is all internal information. I don't think they use it for actual science data stuff, but so on that note, obviously modeling is the big part of what this organization is about. Could you explain what modeling means in this context?
Yeah, so this is numerical modeling, right? So writing code to see if you can capture certain processes that are studying the Earth's surface, or studying the movement of sediment particles, or studying the biogeochemistry that are kind of eroding the soil first, and then using some functions that describe how precipitation or permafrost processes can impact the particle movement. So stuff like that.
I'm sort of familiar with financial modeling, where you're trying to predict stock prices and that kind of thing based on previous numbers. This modeling stuff sounds like that, except with a lot more inputs and a lot more possible outputs, if I understand it correctly.
To be honest, I know so little about financial modeling that I'm not sure if I can compare the two. But yeah, sometimes those there are, for example, landscape evolution models, and they don't look that much. Well, often they look, backwards, kind of. How did we get to the landscape that we are on right now? They could also look forward, but
I see. It's not just predicting the future. It's also
no.
Okay.
Yeah. So it's really to better understand if you can understand the processes that are interacting on the Earth's surface, right? If you over thousands of years, if you can capture. How did the Mississippi Delta, for example, how did that developed over time, or how right now the Mississippi Delta, right, is how would you say that, is shrinking? It's getting smaller, and that part of it is because of human impact. We put up so many dams on the Mississippi that are blocking the sediment basically to get all the way downstream to the ocean. So having those sediments captured behind those dams makes that the delta itself, the Mississippi Delta, can't grow anymore, and it's because it's built of soft sediments. It's still subsiding slowly, and at the same time, sea level is rising slowly. So to understand those processes, how did the delta form over time, and how did vegetation impacted the delta to keep the delta at its place basically when hurricanes are hitting it, and then in future, what will sea level rise do to the delta when there are less sediments coming downstream? So there are all those aspects, different time frames that people are interested in.
Yeah, wow. It just seems so complex to try to model all of that. It incorporates, geology and physics and I guess material science, meteorology. I don't know what else.
Totally. And so there is not. So what we're trying to accomplish is not to have one Uber model kind of where.
Right.
So the community is not building on one model. We have many, many models, and they're all simulating their little part in the system. And they're developed by experts that have studied that little fragment, sometimes for many decades. But it's hard to capture a whole system. So therefore, what we're trying to do, actually, one big task of CSDMS is to, instead of building an Uber model, we want to use all those little models to see if we can couple those models and to simulate a whole system. So
yeah. I want to ask about that, but just briefly, what kinds of things can all this research and analysis lead to in terms of, planning decisions or government regulations or anything else?
I think it gives us a better understanding of the Earth's surface, and it's a very important, like farmers, right? They are very dependent on weather, on climate. And so they really rely on climate models, on weather predictions, on weather forecasts. Well, you can say the same, but on slightly longer timescales for Earth's surface. So what you, for example, see in Miami, there's often flooding going on there with king high tides. Water is actually inundating the land. There's flooding happening from the ocean due to sea level rise. So what can we do to change the Earth's surface to not make that happen anymore, right? And how will sea level rise? How will that change over time? What is the rate of sea level rise? So that's all part of. When I say Earth surface, it's not only the terrestrial part; it's also the ocean part, which is roughly 2/3 of the Earth is ocean. The 1/3 is land. So the Earth,
sure.
ocean circulation, sea level rise. What's the contribution of melting ice caps to the sea level rise? How are how do you call them? I forgot the term. Ocean circulation. How can that change with melting ice caps, and how will that then impact sea level rise locally? So all those kind of things, they're captured in models as well. So that they're also part of the CSDMS models. So
yeah, wow. So I want to ask about the software aspect of all of this. There's a guy named Mark Andreessen who famously wrote in 2011 that software is eating the world. That definitely seems to be the case in science, from what I understand, where for a lot of scientists it's sort of become an IT job, and you have this enormous amount of data that's being generated, and you need to manage all the software that's used to store the data, let alone do data analysis, data modeling, data mining, visualization, export, all that. And then, from what I understand, in a lot of cases there is no ideal software to do all of that. To do that task for some set of data, so you essentially have to create your own software, or at least in some cases. Is all of that true?
That's very much true. Yeah. So the numerical models we have in our repository are developed by mostly by scientists across the world, and they're all, kind of developed by not so much software developers, nor by the Googles and the Microsofts, but really by scientists that mostly have a hydrological or geological background. So they don't have a degree in software development, but they do that on the side.
Right.
Yeah. So it's kind of how would you say that? It's gray software, or it's not.
Yeah,
not your regular software not your gaming software,
well,
right?
Sure.
Yeah.
You say it's not quite. It's more than a pet project, but less than
Totally.
Shrink wrapped software you can buy. So.
Yeah, and sometimes they're. Some people are so talented and they write a perfect code, I would say, and that's great. But also code that just does the job, but is maybe less optimized or maybe less user friendly, can still run, simulate processes and capture processes very well. So
yeah, so. Given how I don't know what the word is. Maybe amateurish isn't quite the word, but given how sort of scattered the whole software landscape is, even now, what were things like when you were starting out? 20 or so, 15, 20 years ago.
Yeah, it was quite a different world, actually. And that's so part of having a CSDMS was, the National Science Foundation has funded for decades professors and students that were developing numerical models for Earth surface processes, right? And typically that is a task for students. They develop this model, and after 4 years of hard work, they run this model for certain applications. But at some point, they're graduated, they have their degree, and they might move on to industry or to another job where they don't use their model anymore. And so the model was developed on their computer, and it never made it to the community. And their supervisors got a different project, and it's kind of sitting there and never used anymore. So the National Science Foundation wanted to have those models, wanted to have a home for those models. Things like GitHub, they did not exist. So GitHub is like Gitbucket or any of those SourceForge, any of those platforms where you can deposit your software. It didn't exist. So we set up our open Subversion SVN environment to host code of numerical models, basically, and that's how we started. And now we moved on and actually have now a repository on GitHub where people can load up their code or put their code, and other people can download the code and make use of it. But it's all, so CSDMS is all about sharing open source code. If it's not enough, it's only an executable, the whole source code should be there, because sometimes, or mostly I should say, it's in the details of the numerical code, how a model operates, that could be important, how to capture a process. So.
Yeah. But I mean, well, modeling is just part of the issue with the software set you need. No, I mean, just
totally. Yeah, there is. So yeah, if you so you can download a model, but you still need your input parameters, for example, to get the model running. And that is, so we don't, as organization, as CSDMS, we don't capture workflows and typically don't have that much input parameters ready for people to work on. It's basically, there are three things that we're doing. One is forming a community, having webinars, having annual meetings, setting standards, that are vetted by the community, that are supported by the community. And then the other part is to build a framework where you can actually link those numerical models. And it doesn't matter if you wrote your model in Fortran or in Python or in C. This platform can couple models as long as the input and output parameters are well described, basically. So that's the second part, and then the third part is more based on exchanging knowledge, education. So we provide labs by something called Jupyter Notebooks. I'm not sure if you're familiar with that, but they're basically you can run models on through.
Oh, Jupyter, yeah, definitely.
Jupyter Notebook, sure. Jupyter Notebook, yeah. So you can run models through Jupyter Notebook. So there are exercises, so people can use those, or professors can use those in their classes. So.
Yeah, that's all Python, or I guess it can also be used to call other software, other languages and stuff.
Python is big, and then I think there are similar platforms for R, but that's less used by our community. What we've seen over the last 15 years or something is that at the beginning, code sharing was not a normal business. That was quite exceptional. People would share code, so that's one. And then two, mostly software was written in packages like MATLAB. So it was for those people, for those researchers that didn't have a MATLAB license, they could not make use of that. Now we have seen a big shift from code written in MATLAB that's now written in Python, an open source code language that everybody can download and start working with.
Yeah, oh, that's great. So, do you think people studying to become scientists should also learn programming? Or is it enough to just know the basics of, installing and running software and Jupyter notebooks and all that?
I think it would definitely help them. If I look at myself, maybe I had had kind of one course. I forgot even the language in what that course was about. I basically learned it myself, and by asking your fellow students and or postdocs when you were stuck in a coding problem. It would have been so helpful if there were a few classes that would just learn you the basics of coding, and also just not only coding but developing a numerical model and kind of get the basics of how you want to structure your model. It would save so much time, and I think there's still there's a little bit more focus on that within at least the Western universities, so in Europe as well as in America. I'm less, and this could be also for universities in South America and Australia, or for that matter, but or Asia, but I just not totally up to date with that. But I've seen a shift that there is more courses are made available to learn modeling, but it's still there could be a bigger emphasis on it.
Yeah. So is science generally becoming, well, as I said earlier, is it becoming more of an IT/data science thing, regardless of the specific sector of science, branch of science you're in?
It's funny that you're asking. I've seen, and this is, so one of the things we provide for our community is some sort of a job list. So whenever jobs are available that we hear from, we put it on the CSDMS page, as long as there is a numerical modeling aspect to it, right?
Okay.
So, and that could be, PhD positions, postdoc positions, but also in industry. If there is a need for a hydrological modeler or something, we will, and we get that through our emails or through some list service. We post that. Now, over the years, we're tracking this since 2012 or 13 or something. Since then, there is a significant increase in the number of jobs that are requiring numerical modeling. We post now at least double the amount of jobs as previous, and it's still a few hundred jobs, but there's definitely an increase there. So yes, I would say scientists are required to get better numerical skills, I think. And not only for numerical modeling and capturing processes, but also for data processing. Data is becoming more and more available, and so large big data sets. So the need to process those to get to to a specific parameter or to a specific outcome requires more modeling. Or more coding, sorry.
I mean, is it true, capital B, capital D, big data with Hadoop and all that stuff that you end up having to use?
Big data, well, so I see it in my role as monitoring flooding. There, I'm handling satellite data.
Oh yeah.
And the sensors that I mentioned before, the MODIS imagery, it's a 250-meter resolution, and it captures 2 images of the world on a daily basis. Yeah. So that's quite a big data set, right?
Yeah.
Now there are there's the private companies like Digital Globe, which is now Maxar, or Planet. They provide data on 10-meter resolution or even half-a-meter resolution images of Earth. And the European Space Agency has radar data on 10-meter as well for the whole Earth. So you can, that's such an upscaling that at some point you don't have the time to process all that data
Right.
and get maps out. So you have to focus on only those areas that are flooding, so that it changes your whole strategy of how to handle, in my case, flooding, right? And the same can be said for other data scientists, I think. It's
Okay.
the amount of data to makes you. I think 30 years ago, you were happy if you got some data that you could then, massage and say something about a process you're interested in. And nowadays it's more like, okay, how can I handle this huge amount of data to get to a maybe more precise answer that I'm after.
Right. Yeah, that makes sense. That's very interesting. Well, I guess we should start talking about Mediawiki. Yeah, I mean, I don't know. I'm personally fascinated by all of this general science and software, and the intersection of those two. And I bet a lot of other people are interested in it. Yeah, it's interesting. Just briefly, I was going to say, whenever you see those posters for STEM, kids should learn STEM. They always show some, group of kids holding up test tubes with different colored liquids inside of them, and that kind of thing. But a lot of it really is just dealing with a computer.
Yeah,
and no matter what part of STEM you go into, it seems like.
It's so true, and I'm mostly my research is either remote sensing, which is behind a computer, or numerical modeling, which is also behind a computer. But I have to say that within my institute, we're so INSTAAR, Institute of Arctic and Alpine Research, we're strong in our fieldwork actually, and studying the environment. So most of the people at my institute, at the institute that I'm working at, they go out in the field for several months a year to collect data. So it's not in every part of science. I think that numerical modeling plays a big role, but okay. I've turned computers into my how would you say that in my life, or I don't know, I'm sure how to express that, but it's my work is all arranged around the computer basically.
Right. So Mediawiki. Have you been using Mediawiki for the CSDMS site homepage since the beginning? So let's see. I came in at CSDMS, so I was a brief period in the Netherlands to get my degree. And then during that time, they started CSDMS. They wanted to have, as one of the first things, they wanted to have a website. So this was a very basic, plain HTML website for the first half year or something. When I came, one of the first things that we wanted to have is to have a portal where the community could contribute to. We thought that was very important, since this is all about community building. We wanted to have their input at all levels. And the other big constraint that we wanted to realize is that we are a community about open source code. So we wanted to use open source code for our organization as much as possible. So Mediawiki is one of the platforms where, you basically need an internet connection and a browser, and you can contribute. So, and it's open source code software. So that's where why we started to implement a Mediawiki software. Yeah. And that was basically there since, I don't know, so this is, I guess, 2008 or 2009. So for quite some time. So it was Mediawiki version 12, 2.12, I think. That's where... it must have been 1.12. It hasn't reached 2.0 yet.
Oh, sorry, 1.12. So there you go. Yeah. And we're at 31 or something now, right? So
35, but who's counting?
35, okay.
35 is about to come out or something like that.
Okay. Oh, that's right. We're running on 34. Yes.
Oh, okay, yeah. Yeah, 35 is going to be exciting for anyone using Visual Editor. It makes, well, if you already have Visual Editor, then it won't matter either way. But
okay, yeah, we haven't implemented.
Oh
that.
yeah, you don't have. Okay, yeah. Well, it'll be
Go
easier.
for it.
It'll be easier to install. I don't know. Yeah. So speaking of extensions, at this point, you're using all of what I would call the big three extensions of structured data in Mediawiki, and I just made up that term, but it's page forms, semantic Mediawiki, and cargo.
Yep.
Apologies
correct.
to Wikibase, which I won't include.
No, correct. Yeah. Yeah, they're awesome. I think for the purpose we're using them. So.
Well, that's great. Yeah, I mean, I know you've been using at least two of those for a long time. Page Forms, which originally was called Semantic Forms, and Semantic Mediawiki, since pretty early on. How did you start using those?
So let's see. One of our repository is the modeling repository, right? And we wanted to have something like a form based where people. We wanted to make it as easy as possible for people that want to contribute to the website to make it able to contribute. So although Mediawiki is very simple to edit, right? We thought, well, can we make it even more easy? And that's by using page forms, or back in the day, semantic forms. And so we implemented semantic forms, but then to capture the data, I thought it makes sense to use Semantic Mediawiki and have that database below it, so you can all the variables that you're saving, you can call on the various pages where you think they're needed, and you can start getting statistics from them, right? How many models are written in C? How many models are written in Python? It's very easy once you got it in a database to extract those numbers. That's why we started to use Semantic Mediawiki as well as the page forms extensions.
Yeah. Okay. And now you use Cargo also for some of the data.
Correct. Yeah.
And I guess I think I've brought it up in every episode so far. The Cargo extension. Sometimes I have to shoehorn it in there, but this time actually.
No, we're using it, and so let's see. There was a reason.
Yeah, I want to ask why.
Yeah. So okay, so it's my laziness, I think, that I'm not have converted all the semantic Mediawiki database to Cargo. It was, that database was already there, but then I'm using Cargo, I think, for the external data extension, if I remember well. There was a reason that's why Semantic Mediawiki didn't capture what I wanted, or didn't have the functionality that I wanted to have the Mediawiki. So I moved on to Cargo. And it's, if I remember well, this was 5 years ago or something. We started to track all the publications that are written for each of the models. So, we have roughly 400 models, and each model there's scientific literature. So we wanted to capture those papers for each model, and on a very easy way. We don't want to burden people with typing in the author, the co-author, the title, which journal, and which year it's published. All that kind of things. We wanted to capture that by, people should be able to post their DOI, so that the digital object identifier. It's unique for each paper.
Right.
People can type that in, and then database automatically gets populated with author's title, year of publication, everything. So people don't have to go through that. exercise of typing that themselves. And I think that connection with the external data extension and then capturing the various data, for some reason I couldn't work that out with Semantic Mediawiki, so I started using Cargo.
Oh, okay.
So.
I mean, it all works with Semantic Mediawiki also in theory. Who knows? But
Okay.
yeah. All right. No, I mean,
Okay. Or it was just, maybe it was easier to capture, or I don't know, or you had an example on one of your pages that I thought, okay, that's easy. I can just copy this, and so that might be as well.
Yeah. Okay. Cool. So of course we talked for a while about the use of software for managing scientific data. I have to ask: is there any chance that Mediawiki will make the leap and get used for storing actual scientific data in one way or another? Do you think?
So, I'm not sure. I'm not sure if it's the ideal software to do so. To store the raw data, the kind of data that is captured in the field, or what we do use it for is to point people to input data, right? Where that's stored somewhere else, climate data sets or groundwater data sets or population data sets, but it's not that the actual data is put on a Semantic Mediawiki. It's more like we have a form there as well that people can fill out, and then to advertise their data sets basically.
Yeah, I guess you can call it metadata, even though that
right.
term is overused.
Correct.
But yeah. So what are the types of data being stored on the wiki? We haven't actually talked about other than information about the different models.
Yeah, the most of the data that we're storing is exactly what you said, the metadata, and it can be metadata about models. So the actual source code is often on Gitbucket, SourceForge, GitHub,
right,
GitLab. But then the metadata of that model is captured on the Mediawiki. The same for data sets, the same for educational data sets. Actually, we have some data on our server and that's then basically because people didn't have a local facility, a local server that they could use for their data sets. So they asked if we could serve it for them. So that's kind of through the Mediawiki. But it's other than that, it's mostly metadata about metadata of papers, reference data, metadata of data itself, metadata of models, and that's what we store.
Yeah. Okay. Yeah, and actually, before you mentioned job listings too.
Yeah. True. Yeah. So job listings, and also important conferences or meetings or workshops that we think have a kind of a modeling or numerical modeling kind of
component,
right? Yeah, exactly. Thank you. Component. Then we list those as well, and that's all kind of captured in Semantic Mediawiki, and through forms people can submit those and advertise for those jobs, for those workshops, or
and you're basically the Mediawiki person. You're the person who would create a new data structure, or say we should.
That's correct. Yeah.
Okay.
Yeah, and sometimes I might have done a sloppy job or anything, but I try to set up the structure. I hope that people contribute, and often that happens for when people want to highlight their paper that's just published, they will often put it on there, or when they want to give more attention to their model, they enter their model. But most of the content that you will see on there is either put up by me or by our group.
Oh, okay. Yeah, I was wondering about that. How widespread the editing is.
Yeah, it's really so community is contributing where it has a little impact for them, right? If they want to advertise their workshop or their conference, so they typically enter those kind of things or often. And sometimes that's the same for jobs. If a professor is searching for students, they post those jobs also on our site, and the same for their models and their papers. But many other things are just put on by me or by somebody in the little CSDMS facility group.
Yeah. What's the viewership like of the wiki?
So we use Google Analytics to track that, and so NSF requires us to every year put out an annual report so they can evaluate if we're doing well for this project. So I just on an annual average, I just had to produce this number. It's slightly over 500 viewers per day, unique viewers.
Yeah.
So
yeah,
that's
really good
for mostly serving science, the scientific community. So that's reasonable views.
Yeah, it's clearly not just if you have 2,000 members, that's clearly not just the membership of the organization that's going to the wiki.
Correct. Yeah. No, that's from outside as well, and we still got new members. Roughly 100 to 120, 30 or something people every year. So that means that new people are somehow got to our page and show interest. So they're not only the community members that make use of this page.
Yeah. So I want to ask. I mean, I can't really disagree that Mediawiki is not ideal for storing, huge amounts of raw data. But what about use by scientific labs to manage their internal data? The kind of, I guess, metadata that you're talking about, but internally within labs or departments or stuff. I don't know if you're using Mediawiki for that. If there's some other private wiki somewhere, or if you have any thoughts about that.
I'm part of a group that is interested in. We touched upon this earlier in our conversation about erosional processes. Certain surfaces erode more than other surfaces, right? The rock is stronger. Or weather processes are different in the tropics versus the temporal zone or versus the Arctic. So this group is interested in those erosion rates, and we started to build a global database of erosion rates, basically. And this makes use of Mediawiki as well. So there, I know it's used to store data. I have not heard of many other groups that are using Mediawiki to store data. At least not at our institute. I think we are the only group that uses Mediawiki for that.
Oh, okay. What do other groups use for anything from staff directory to list of analyses that have been run or whatever else it is?
I think the university itself has I think software. I think it's based on Drupal. And many of the departments are using Drupal for their kind of internal organization to store data and to manipulate data. It's very field specific, I think, and I'm not sure what they are using all. But I don't think it's really web based. They're right.
Well, okay.
They're supercomputers that hold data, that process data.
Right, yeah.
Right, and they are they have it's very unique software that's implemented for that.
Yeah, I guess it makes sense that the same software that's used to store the massive amounts of data can also store the peripheral stuff. Yeah, all right. And if it's Drupal, I can't complain because that's open source too. So that's
right. True. Yeah. Although some of their at some point I was looking into that, and many of their extensions you have to pay for, whereas the Mediawiki community is a very much open source driven, free to use kind of. So.
Yeah, that's true. There isn't the marketplace or whatever like there is for Drupal and WordPress where.
Yep. Yeah.
Yeah. Okay. Cool. I think that's it, and we've been talking for a little over an hour, so.
Oh, cool! Wow, time flies.
Yeah. Okay. Great. Yeah. It was very interesting. Yeah. Is there anything we didn't cover that you wanted to?
No, I think we touched base upon many things. I hope people have a better understanding of CSDMS now and the way we're using Wiki and why we're using the Wiki. So, yeah, I think this captures it pretty well. Yeah, thank you.
Yeah, great. Yeah, I certainly understand it a lot better now. And just the whole concept of modeling and earth science. If I can call it earth science, you never actually use the term earth science, but I think,
no, there's so many terms, and what I tried to do was not to use too many words that are so scientifically that anybody outside science wouldn't understand them. So I tried to keep it as basic as possible, but as understandable as possible, I should say.
Yeah. Well, yeah, clearly all of you are doing really important work, and it's great that all of the Mediawiki developers listening, myself included, I think can take some pride in being a part of that in some way.
Yeah, thank you, Yaron. Yeah.
Well, yeah, I wasn't really fishing for compliments, but all of us in general. Well, yeah. Okay, great. Yeah, it was good talking to you, Albert, and thanks for coming on the program.
It was a great opportunity, and I'm glad to now have met you in person instead of through emails, like what we had done over the last several years, I think decade even. So thank you for giving me this opportunity to speak more about CSDMS. So appreciate it.
Great, absolutely. Thank you. And this has been another episode of Between the Brackets. I want to again thank my guest, Albert Kettner of the University of Colorado and the Community Surface Dynamics Modeling System, for a great interview about science, technology, and a few other things. Thanks to all of you for listening. Stay productive, everyone, and I'll see you next time.